Good morning. Today you are going to see about testing of materials, in particular Unit 1, Introduction to Material Testing. The material testing is a general introduction unit, the first unit. In upcoming units, you are going to see about the destructive testing, non-destructive testing, and material characterization testing. First one, the overview of materials. The material is defined as a substance which can be either of solid, liquid, or any gaseous form. These materials can be used in various applications, from buildings to various spacecraft applications. Materials can generally be classified into crystalline, non-crystalline form. So, for example, it is further classified into metals, semiconductors, ceramics, and polymers. The further advanced materials will be nanomaterials and biomaterials. These are the roles to be considered while doing material testing. So first one is you have to analyze the particular material behind its theory, processing, characterization, and its mechanical properties. So the theory behind is you have to analyze the material structure and the bonding structure and all. The processing is once the material can be chosen, that specimen can be selected and that can be further goes under further processing like rolling, forging, stamping, drawing, etc. The characterization of materials can be analyzed with the help of some microscopes. So the image based analysis. Next one is your mechanical properties. The mechanical properties is, for example, if you consider metal, the metal has a property of hardness, ductility, fracture, creep. Various behavior can be measured with the help of this mechanical properties analysis. So first one is your classification of materials. The materials can be generally in broadly classified as metals and non-metals. The metals can be ferrous and non-ferrous type. Non-metals can be plastic composites and ceramic type. First one is your metals. So metal is an opaque, lustrous element which is a good conductor of heat and electricity. The metal can be reformed into various shapes such as under the property of malleable and ductility. So further, the metals can be classified as a metallic and non-metallic elements. Some of the examples of metallic elements are iron, aluminum, copper, etc. The non-metallic elements are carbon, oxygen, etc. This aluminum alloy can be generally used in spacecraft applications. Next one is your metal alloys. The structure, the diagram represents the various bonding, microstructure, advantages and disadvantages of metals and alloys. The bonding of metals and alloys is metallic bonding, as the molecules inside the metals will be closely packed structure. So due to this tightly packed structure, the metal possesses the property of strong and stiff hardness. The microstructure of a particular metals and alloys is mainly a crystal grains based structure. Crystal grains based structure in the sense it contains a n number of small crystal based structures which are closely packed to form this metallic bonding. The advantages is strong, stiff, ductile, and metal, as aware of metal, can be easily conductive. The only drawback of metals and alloys is the disadvantages is fracture and fatigueness. So fracture means it can be easily breakable under subjected to a temperature under aging. The fatigue in the sense the metal loses its original property under aging. So that is the term fatigue. Next one is your ceramics. The ceramics is an inorganic non-metallic solid made up of either metal or non-metal compounds that have been shaped by heating with a high temperature. So what they are saying means the ceramics can be shaped as per our requirement when subjected to a high temperatures. Next one is your, it is a composition of metallic and non-metallic elements such as oxides and nitrides. This diagram shows the bonding structure, microstructure, advantages and disadvantages of ceramics. The picture here shown here is generally of conductors. The conductors are mainly used in transformers. Why? Rather than preferring metals, they are using ceramics and glasses in the sense. The metals, if metals are used in transformer power transmission application means, so it possesses the property of corrosion. So the corrosion of material will makes the power loss. So the ceramics will be used. So the ceramics will have the bonding of ionic covalent, which has a microstructure of crystal grains, and it possesses glasses will possess the amorphous forms. The advantages of ceramics and glasses are that it is strong and stiff. Even though if it is strong and stiff, it has a good property as temperature resistance and corrosion resistance. But even though this advantages is overcome by disadvantages, easily breakable. Polymers. A polymer is a large molecule or macromolecule which is composed of many repeated subunits. Many repeated subunits, each structure has some molecules. These molecules are repeatedly arranged to form the closely packed structure. The further classification of polymers is synthetic and natural polymers. Example of these polymers is carbon, hydrogen, and various non-metallic elements. The structure shown here is depicts the bonding structure, covalent and secondary bonding. The microstructure of a polymers involves a chain molecules. Chain molecule in the sense, as I said earlier, the repeated subunits of molecules are arranged in order to form a particular polymer material. The major advantages is low cost, low weight, and resist to corrosion. So low cost and low weight means you might have seen these water bottles, containers, and toys which have been shown in the slide. This can be widely used, but it can be easily breakable. So that is a major drawback of polymers. So the strength and stiffness will be of low. Next, composites. A composite is a material which is made up of different materials as per our requirement and as per our application. For example, for a particular application, you are in need of individual properties such as it should resist corrosion and it should be a lightweight. For example, considering glasses, ceramics, and polymers. If you combine these three materials in order to get a different new material, means that material is called as a composite material. So these material characteristics will be different from that of original components. So the major drawback of these material will be a high cost, because a number of process and stages involved in order to combine n number of materials to form a single composite material. So the cost of composites will be high, and the major drawback again is delamination. Delamination in the sense, once the material will be started to use in a particular specific application, under aging, so it start to separate a layer by layer. Why it is separating into a layer by layer means, so we are using various materials to form a single material. So these material will have different properties. So each and every material will possess different properties and different chemical properties. So these, due to this molecular arrangement, the material will start to separate it layer by layer under aging. So next one is your advantages. The advantages of composites will be strong, stiff, and lightweight. As different n number of materials are combined to form composites, so it possesses a various bonding structure. So the microstructure of a particular material will be of matrix and fiber. So these are some advanced materials, that is CD, DVD players, that is mainly used in military and rocket, aircraft, spacecraft, LCDs, fiber optics. This advanced material will possess some high technologies, recent technologies to process these materials. Some of the advanced materials are semiconductors, biomaterials, smart materials, and nanomaterials. These materials generally used in medical applications. These biomaterials, smart materials, and nanomaterials. As many researchers are going in order to study these type of materials. Next, this is a comparison table in order to compare various properties with the various elements. So the bonding of metal, ceramics, polymers will be compared. So what they have analyzed in the sense, the compressive strength of metal, ceramics, polymers varies from material to material because the bonding structure will be varied. So the strength of the material will also be varied. The corrosion resistance of particular material will be low in metals, and ceramics and polymers, it is a superior and medium one. The electrical conductivity of metals will be high. In terms of ceramics, polymers, the electrical conductivity will be low. The fracture toughness, metal, it cannot be easily breakable, but ceramics and polymers, it can be breakable. So that's why the fracture toughness will be low in terms of ceramics and polymers when compared to metals. Next, the thermal conductivity will be high in metals and low in ceramics and polymers. Next one, the testing of materials. So the material testing will be classified into broadly 3 categories, such as destructive testing, non-destructive testing, material characterization testing. Why we are in need of testing a particular material before processing into a product? That is, in order to obtain a special standard and procedures for testing. So you have to establish the particular, analyze the properties of material. So in order to analyze that particular material, various testing methods are needed. So these are the methods. So in upcoming chapters, we are going to see about destructive testing as an individual chapter, non-destructive testing, material characterization testing. So first of all, I would like to explain the definitions of destructive testing, non-destructive testing, and material characterization testing. So first one is your destructive testing. So destructive testing, in the sense, the material taken under the analysis of a process will be of destructed one. So once the specimen is subjected to a testing, means after that, that specimen cannot be used for further manufacturing process. That is a destructive testing. Non-destructive testing is that specimen subjected to a testing process will be of reused after the testing process. That is a non-destructive testing. Material characterization testing is, as I said earlier, by enlarging images obtained with the help of macroscopes and microscopes, various spectroscopic and diffraction techniques. N number of techniques are used for material characterization testing. Further, the classification of destructive testing includes static, impact, cyclic. So the name itself indicates static means you are going to vary the load at a gradual instant. So gradually you are going to vary the loads, and in cyclic testing, you are going to vary the loads of different magnitude and different directions. That is a classification of destructive testing. These are some examples of static testings, dynamic testing, and cyclic testing. Next one is your advantages. This destructive testing is majorly used to identify the mechanical properties of a material. So it performed under cheaper cost. Disadvantages is you cannot identify the internal defects. Non-destructive testing is you are going to use some sources in order to test your property of material and in order to test the cracks which is present on the surface of the material. These are the some of the sources: liquids, radiation, sound, magnetism, and infrared. These are the types of non-destructive testing. So acoustic emission, they are use some sound waves, or infrared testing, they will use infrared rays. Liquid penetrant testing, they will use some spray like liquids in order to test the surface. So various testings are here. These will be dealt in further chapters. Non-destructive testing as a separate topic. Next one is these are the examples of advanced testing. So electromagnetic, magnetic flux, laser testing methods, everything.